Hello students, welcome to this lecture number 8 on thermodynamics. In this lecture we are going to discuss a very important topic in thermodynamics chapter. We know enthalpy is a state function, means enthalpy of the reaction depends on the initial state and the final state, that is the reactant and the product, that is the enthalpy of the reactant and enthalpy of the product. It do not depend on the path. Path means how many steps has been taken to produce that reactant into the product, means that convert the reactant into the product. So it is a state function, and so its value do not depend how many steps it has been taken to convert it. So this has been described in a law. This law is called the Hess law of constant heat summation. Means when the reaction will carry out only single step or in the different steps, that total amount of the heat involved in that reaction will be the same. So in this lecture we are going to discuss this important law, the Hess law of constant heat summations. Hess law of constant heat summation. It states that total amount of heat evolved or been absorbed, because in the reaction there will be heat, either heat will be absorbed or heat will be evolved. So total amount of heat dissolved is independent of the steps involved in the reactions. Or we can write the another way is same. We can write same is same whether the reaction is going on in one step, means single step, or more than one step. So this is the thing, that total amount of heat absorbed is same, whether the reaction is going on one step or more than one step. As for example, we take the example of this carbon plus oxygen gas. It will going to prepare the carbon dioxide gas. At that time, enthalpy involved, means heat evolved, because this is the exothermic reaction. At that time it has been found out that it will be 393.5 kilojoule per mole. Now this reaction can be carried out in two steps, that we can see. First, it will react with oxygen and it will produce the carbon monoxide. This is the step 1, and at that time what is found that
At that time it is found that 283 kilojoule per mole. Second, this is step 1. The product has not been produced. Another step it will involve to reach the product, that is carbon dioxide, it is CO2 gas, and at that time the enthalpy of reaction, it has been found minus 110.5 kilojoule per mole. Now we see in the single step you have this amount of heat evolved, right? Now same reaction is carried out in the two steps, first steps and second steps, and at that time you will find the heat absorbed, heat evolved by this reaction is same. So heat evolved by this reaction, by this first reaction, that is the step 1, step 2, sum of them is the same as it is evolved in the single step, and that is what it is being told. So this is a very important rule, we will say, important law, that is the Hess law, that I think that is very much clear to you, that heat will evolve or absorbed by the reaction, it will be always same, irrespective of how many steps it has taken. It may be taken 2 steps, it may be taken 3 steps, 4 steps. That is not so much important. Important is how much heat has evolved, and the summation of this heat will be same if the reaction is carried out in single steps. Okay, that is what Hess law says. Now we will understand this more clearly with some numericals. Okay. Now we can see from the Hess law how we can able to solve this problem. You have to calculate the heat of formation of NCl3 gas in the form of these enthalpies. An enthalpy of the reaction of some other reaction is given, that is this reaction is a reaction number 1, reaction number 2 and reaction number 3. From this you have to calculate the enthalpy or heat of formation of these reactions. Means first, for this type of questions, what you have to do, we have to first make a mental picture. Mental picture means what you have to do. What you have to do now to find that is the heat of formation of NCl3, means N2 plus Cl2 is equal to NCl3, and at that case we have to calculate this, we have to balance it, that is by 3 by 2, that is half. And this equation you will form these equations, 3 equations, and when this equation will be formed and you have to multiply some factors, you have to subtract these reactions, and accordingly this enthalpy will be changed. Okay, that we will give this. How do you do this? That is a question. First you have to show this reaction and all this reaction, how you have to apply this factor to these equations. See, you can easily understand how you can able to do this. First what we will do, this is a reaction 2, we have to get the half N2, right? Then we have to get the plus 3 by 2 Cl2. That you can do. First what we will do, first the equation number 2 will be multiplied by this minus half factor, and this equation we will subtract with this equation. After equation number 3 will be multiplied by 3 by 2. That will give this 3 by 2, and you will get this half. Okay. Then what we will do, we will just add this first reaction, equation number 1 will be added. So what will be this enthalpy of the reaction? You can easily understand. With this operation, you will get this, and how you will get this? You can calculate yourself. You can find that from this reaction how you will get. Let's see. When equation number 2 has been half, this means half into plus 3 by 2 H2, right? Then we are just taking the left hand side, then we will take the right hand side, okay? This, and then we have to minus this 3 by 2 H2, this second equation, third equation, H2, and this will minus 3 by 2 Cl2, okay? Then you will get the equation number 1, that you have to just add it. You will get this NH3 plus 3 Cl2, okay? Now go to the right hand side. In the right hand side, what is there? NH3 plus 3 by 2 मतलब 3 HCl, 3 HCl, that will equal NH3 plus 3 HCl, and you can get here NCl3. We will add this NCl3, this will be minus plus 3 HCl. So ultimately, if you get all this, thus you will get NH3 and NH3 will cut, then 3H2 will cancelled, and this minus this will ultimately get this equation, that is half into plus 3 by 2 Cl2, and it will give the NCl3, and in this case the heat of reaction will be, accordingly you have to multiply this, you have to multiply by this minus H2 by 2, then this will be 3 by 2 delta H3, and it will be H1. So this will be the heat of reaction, and this is the E. So in this way we can able to calculate the heat of reaction, here heat of formation of NCl3, from the given equations by multiplying factors, and after this factor you have to mentally see which type of operation we have to do, from which equation we have to subtract it, from which equation we have to add it. Here see in the equation number 2 with the factor half, and with that we will minus with the equation number 3, and then we again add with the equation number 1. So we will get this equation, and accordingly the enthalpy of the reaction is this. This is another very important question that you can love to solve it. It's a very important question and very useful question. For allotropic change represented by this equation, graphite to diamond, this reaction has been given. The enthalpy change for this reaction, it will be endothermic reaction, and there is a absorption of energy of 1.9 kilojoule. If the 6 gram of diamond and 6 gram of graphite separately burned to yield the CO2, the heat liberated in this case, there is the 4 option is giving, less than in the second case by 1.9 kilojoule, more than in the second case by 11.4 kilojoule, more than in the second case 0.95 kilojoule, and less than in the list. There is 4 options. You can do one thing. You can pause the video and you can solve yourself. Think yourself for a while. After that you see the solution. Now I am going to solve it. See, here this is a combustion reaction. Okay? At that time, graphite, carbon is a form of, graphite is a form of carbon. From the carbon it is allotropic modification, you know. And this carbon, when combust, burned in oxygen, it will going to give the carbon dioxide. Suppose at that time the enthalpy change is minus X, suppose. And this carbon, this is a diamond, okay? We take the reaction of for the diamond. Diamond is basically carbon, nothing else. And it will going to produce the carbon dioxide. And at that time, the enthalpy change is suppose minus this. It has been giving both the enthalpy change. This equation is given. But we will form this equation from these two equations. Okay? So if we subtract this equation, we will get the graphite to diamond. Understand? How do you get this reaction from these two reactions? We just subtract it. So ultimately when you subtract it, oxygen will and carbon dioxide will be cancelled each other. So in this case, the enthalpy of reaction, suppose this is H3, will be minus X plus Y. And that has been given here that Y minus X, we can write this Y minus X is given by 1.9 kilojoule. Means what? The enthalpy of combustion for the diamond, this is diamond, will be more than 1.9 plus X. This is more than by 1.9 kilojoule per mole as compared to the graphite. Now the question arises, sometimes student what tempted to take this A answer. That will be the wrong. Because it is been given 6 gram of diamond. Means this is the enthalpy for the 1 mole. You have to go for the 0.5 mole. So when it is having the 1 mole, then for the 0.5 mole, what will be this? Now, Y is equal to 0.95 plus X. So this option will be the correct option, we will see. So you have to be very much attentive when you are going to solve any question, and when multiple choice is there. Then at that time the answer will be 0.95 because it is given for the 1 mole. Enthalpy means 1 mole. We already understand, we already studied in our previous lectures that you can go through that. But for 1 mole, how much heat is required? That will be the enthalpy of the combustion. Okay, so this will be the answer, that is more than in the second case. More than in the second case means first case is the diamond, second case is the graphite. So diamond will have 0.95 kilojoule per mole than the graphite. Okay, and that is all for today's lecture. Hope you enjoyed this lecture. If you like this lecture, you can share with your friends. Thank you for watching. And the next video, we will meet with another very important topic, that is the spontaneity of the reactions, and we also discuss the second law of thermodynamics. So far we are discussing regarding the first law. Now we will go to the second law. Till then, all the best and be best.